Lesson 7. The Cycle of Remainders. In the previous lesson, you learned that the remainder in a division problem is always less than the divisor, that is, the number that you are dividing by. For example, consider a divisor of 4. When you divide the numbers 8 through 11 by 4, the remainder is always a number from 0 to 3. Note that in each case, the remainder increases by 1. However, when you divide 12 by 4, the quotient is 3 with a remainder of 0. This pattern continues when you divide 13, 14, and 15, and again resets to 0 when you divide 16. This pattern, in which the remainder increases by 1 and then drops back to 0, is called the cycle of remainders. Notice that in this case, the cycle of remainders goes from 0 to 1 to 2 to 3, and then resets back to 0. This is because when the divisor is 4, the remainder must always be less than 4. As another example, when you divide the numbers 14 through 20 by 7, the remainders are the numbers from 0 to 6. When you divide 21 by 7, however, the cycle of remainders resets to 0 and then continues. You can use the cycle of remainders to perform difficult calculations easily. For example, suppose you know that 132 divided by 9 equals 14 with a remainder of 6. You can use this information to show that 133 divided by 9 equals 14 remainder 7, and 134 divided by 9 equals 14 remainder 8. However, when you divide 135 by 9, the result is 15 with a remainder of 0, which begins the cycle again.